Before we dive into the course on how to conduct a CBA, I want to share with you what results you're really working towards here and how you can interpret them. We believe it is easier to learn new skills if you know your goal and what you're working towards. So once you're done with your CBA, you will be able to analyze your data and have key result indicators that will help you make an informed recommendation. You can use them in a decision matrix to facilitate internal or also external decision making. These are the 5 key indicators we will discuss. Number 1, benefit cost ratio. Number 2, the affordability for the farmer. Number 3, the payback period. Number 4 is the productivity per square meter. And number 5, the complexity. Let's talk about the benefit cost ratio, or short BCR. We have chosen a simplified way of calculating the benefit cost ratio. It basically takes the sum of all benefits occurred over the lifespan of the hydroponics unit, divided by all the costs. So very simply put, benefits divided by cost gives you the BCR, the benefit cost ratio. Once you have calculated this, you will want to know what it means. So now let's look at the interpretation of this indicator. If the BCR is below 1, that means the cost of the project outweigh the benefits and the project should not be implemented. If the BCR is equal to 1, the costs equal the benefits and the project should be reviewed in terms of viability. You should really understand are the other aspects why this project should be moving forward. If the benefit cost ratio is, however, larger than 1, the benefits outweigh the cost and the project is economically viable. Ideally, the BCR for hydroponics units should be above 3.5, and you should try to identify ways in which this ratio can be further increased as a first step by, for example, decreasing the capex. And just to give you some extra motivation here, if you adjust some of the designs in the field and this number and this ratio can increase, it truly means that you're creating more impact for the people we serve. This is why this analysis is so important, and this is why we care about it. Let's talk about indicator 2, monthly affordability for the farmer. This indicator is at the heart of the project, right? It is the ratio between how much farmers gain on average per month and their average spending per month on farming hydroponics. Let's look at a simple example. Imagine a farmer gains $20 per month from selling their surplus in vegetables, and they spend $6 per month on seeds, nutrient, and upkeep. Then the affordability of their unit on a monthly basis is 3.3, which is the benefits divided by the cost, right? It is $20 divided by $6. This means you can not only compare this with the affordability of traditional agriculture, if that's possible, but you can also compare different options of hydroponic systems just by using this ratio. Let's assume to achieve the same amount of harvest you have 4 options that you're looking into. Let's look at option 1. You see traditional agriculture using microdosing of fertilizers on 1 hectare of land. And you realize when you divide the benefit with the cost, you get a ratio of 3.0. Option 2, you have a vertical system on a rooftop and you realize the ratio is 3.3. Option 3, you have a horizontal system on a rooftop and it provides you with a ratio of 3.0. So the benefits divided by the cost, 3.0. And then option 4, traditional agriculture renting 2 hectares of land is 2.8. Here, for example, the farmer has to rent land, so it produces additional cost, which then also brings down the affordability ratio, 2.8. So look at this calculation here. The hydroponic system actually in option 2 would be the most affordable option. The explanation behind these numbers could, for example, be that renting land or access to land in the respective location is very expensive. If the ratio is lower than 1, the system is not affordable and should not be implemented. A ratio above 3 will have the optimal long-term sustainability for the farmer on a monthly basis. So let's dig deeper. I want to inspire you with 3 examples that may help you to understand the affordability of the hydroponic systems for the farmer in your country's context. Option number 1. You can look at the average monthly household consumption of the respective location as a proxy to understand affordability of the running costs. You can find the data online on the National Statistics Office as part of the household budget surveys. Usually, they're very easily accessible. Let's give you an example. In Tanzania, I looked up the average monthly consumption in Rukwa is 59,000 Tanzanian shilling, or the equivalent of around $26. Having that data point helps you enormously in putting the affordability for the farmer in the right context. Meaning, how much income would they usually have? Would they have any form of income source or money? And how does it look like in the country's context? Option number 2. Or you can use the final consumption expenditure, which provides an approximate measure of income and consumer spending power, which impacts the affordability of foods and consumer behavior. You see here I included a source that can actually help you get that data in 5 minutes. It's called the Food Systems Dashboard, which has data on diets and nutrition. Option 3, you can include the cost of nutrient adequacy. So I looked up in Chad that the Kona is actually 92% of the household food expenditure, which is 412 francs per day and 12,000 francs per month, or the equivalent of around $23. So you can see here, this is how much people need to spend in order to have nutrient adequacy. Now, in the context of this data, imagine a farmer gains $20 per month from selling their surplus in vegetables, and they spend $6 per month on seed, nutrient, and uptake. The net benefit would be $14 per month, which would mean, in the example of Chad, it's a 61% of their monthly cost of nutrient adequacy. So putting that data point and putting that result in this context for the country really helps make it understand, really helps to inform your decision. Let's look at indicator 3. This is a simple one, payback period. The point in time that the cumulative benefits exceed the cumulative costs is your payback period of the project. In other words, the year following the project payback period will see net profits or benefits to the project. When considering loans or subsidies, for example, the payback period should focus on the value of production and sales of surplus and not include benefits that are more difficult to measure. Let's look at the indicator 4, productivity per square meter. This is fairly simple. Comparing different options based on kilograms produced per square meter can help you understand which option has the higher productivity. This can be especially helpful in the decision making when comparing different hydroponic systems or setups. And then the indicator number 5, the net present value. Since we're looking at a longer time span, CBAs can sometimes fail to take into account other factors like inflation, interest rates, and other larger, more long-term factors. This is why it is advisable to add the net present value formula to have additional ways of comparing your options. Imagine your hydroponics unit has a lifespan of 10 years. And then you basically just value the benefits that are created over time differently. If the net present value is larger than 0, the benefits outweigh the cost and the project is economically viable. The NPV is calculated using the sum of all benefits over the lifespan of the unit minus the sum of all costs over the lifespan of the unit. Important is, as I explained in the beginning, that we value benefit that we create immediately higher than value that we create 10 years from now. Because there is a risk that this value might not happen in 10 years from now, right? It's more uncertain. And because of that, we discount it. We take off some of that value. And in order to do that, we use something that is called the discount rate. Here in this formula, it's the small r. This can be different depending on location and risk involved. The discount rate is an interest rate, basically, that takes the cost of capital into account. Fair to assume a rate between 5 to 10%, and in our example template that you will find at the end of the training, we use 5%. We have integrated a lot of formulas in that template so that you have an easier and faster time doing your analysis. However, it is very important to understand why you're doing it and what the results mean. So I have included here also an indicator that is not based on one of the results of your analysis, but is still very important when you make decisions or facilitate decision making for others. Indicator number 6, complexity. This indicator will not be a direct result of the CBA, but you can include this as an outcome from additional qualitative interviews with farmers. You can rank the complexity for the user, for example, on a scale from 1, which is low, to 5, which is high complexity. This can be a very helpful way to include the farmer's perspective when comparing different options. So let's put the results into context and compare your options. You have 5 key indicators: benefit cost ratio, affordability for the farmer, payback period, productivity per square meter, and the net present value. You can decide, based on your context and needs, which others to include in your analysis. However, we recommend to include these as a minimum in order to compare your different options in the most impactful way. We have also included some useful resources for you here. For example, the food systems dashboard that I mentioned, the FAO food price index that can be very helpful to understand or also find average market prices, and the consumer price index. So good luck, and see you in the next session on looking into the cost-benefit analysis of animal feed. Thank you very much.